Good afternoon, everyone. It's a real pleasure to be here to share insights on platform engineering for AI-powered healthcare, native mobile architecture. Over the last decade, healthcare has shifted from being hospital-centered to being increasingly mobile and patient-centered. Mobile health devices are now essential for remote monitoring, telemedicine, and personal health monitoring. Along with with the AI integration, these platforms are becoming intelligent companions that help doctors empower patients and more make care more proactive. My name is Srikanth, and in this session, I'll walk through you how platform engineering, native mobile architecture, and embedded AI combine to deliver scalable, secure, transformative healthcare applications. For instance, during COVID 19, AI apps helped hospitals manage patient flow by flagging urgent use cases remotely before patients even arrive at ERs. That movement showed how digital platforms can directly save lives when engineered for scale and intelligence. Let's go to the agenda. So in this agenda, we'll be having a brief introduction. In this introduction, we'll cover about the convergence of platform engineering and healthcare technology. The second slide will be covering about native mobile architecture, the foundation of healthcare platform engineering, embedded AI integration, transforming healthcare delivery through intelligent platforms, HIPAA compliance and security, why architecture must embed privacy and trust. Real-time health monitoring is one more aspect. Engineering platforms are for continuous care. And the other aspect is clinical decision support, AI-enhanced care quality and outcomes. And the last point is the future directions. Emerging technologies drive healthcare's next evolution. Along the way, we'll also highlight areas like patient engagement, scalability, and strategic build. So, in this slide, we'll be talking about the convergence of platform engineering and healthcare technology. Healthcare systems Healthcare systems worldwide face major challenges like aging population, rising chronic diseases, illness, and overstretched capacity. Traditional models of care can't keep up with these demands. This is where platform engineering plays a pivotal role. Instead of building isolated apps, we design platforms, reusable, scalable, and secure foundation that can serve multiple healthcare needs. This shift means developing reusable components instead of reinventing the wheel, and also using standardized interfaces so hospitals, devices, and insurance can connect seamlessly. And the other aspect is building scalable architectures that reliably handle millions of patients. This mindset prioritizes reliability, observability, and maintainability, all of which align perfectly with healthcare's needs for consistent, safe, and auditable systems. So, a UK hospital network demonstrated this when it built single shared platform for appointments, telemedicine, and vaccination tracking. By reusing components across apps, they cut development time significantly and improved system scalability. So, in this slide, we'll be talking about the native mobile architecture foundation for healthcare platform engineering. Why is architecture so critical in healthcare? Because here, performance and reliability can literally mean the difference between life and death. Native mobile health Native mobile development enables real-time responsiveness for alerts and monitoring. Latency is unacceptable when the patient's heart rate drops. Enterprise grade security is also one more aspect. Through enterprise grade security enhances a deeper OS integration with encryption and secure storage. The other aspect is hardware integration with glucose monitors, ECGs, and blood pressure cuffs. Offline capabilities that allow critical features to work in low network and or rural areas. This makes native architecture the bedrock for safe and dependable healthcare platforms. For example, an Android based diabetes care app connected directly with the Bluetooth enabled glucose monitors. Patients receive instant alerts for abnormal readings while doctors get accurate and secure data streams. That immediacy would not have been possible with a hybrid app approach. So, in this slide, we'll be talking about embedded AI integration transforming healthcare delivery. AI transform healthcare platforms from reactive tools to proactive tools. Instead of taking the decision, instead of taking some actions after something has happened, it's like a proactive thing. We try to predict the things and stop the things before happening. So with frameworks like TensorFlow Lite, we can now run machine learning models on mobile devices themselves, keeping sensitive data private while enabling faster analysis. Some of the most powerful capabilities include predictive analytics to spot early warning signs of healthcare deterioration, personalized care recommendations tuned to each patient data, clinical decision support, offering evidence-based suggestions for doctors. This shifts this shifts healthcare from waiting for problems to arise to anticipating them and intervening early. In India, a mobile eye care app used embedded AI to detect diabetic pathy from smartphone images. Rural clinics often lacking eye specialists could suddenly screen and refer patients early, preventing avoidable blindness. In this slide, we'll be talking about the compliance. In this slide, we'll be talking about HIPAA compliance and security architecture in AI-powered healthcare platforms. In healthcare, compliance isn't optional; it's foundational. Every platform must guarantee data encryption, both in rest and in transit. Access control with role-based permissions, biometrics, and multi-factor authentication. Audit trails that log every data interactions securely. Some AI models are even trained to operate on encrypted data through advanced methods, further enhancing privacy. The most effective platforms build these compliance measures into the architecture itself, ensuring every application developed inherits them automatically. We saw this with the US telemedicine provider that restricted test result access strictly to physicians, not administrative staff. This not only helped them meet HIPAA standards, but also increased patient trust in the platform. The next slide, I will be talking about real-time health monitoring engineering platforms for continuous use. Healthcare is no longer confined to hospitals. Patients expect 24/7 monitoring wherever they are. Platforms must support sensor integration with wearables and implantables. Edge computing to analyze signals locally without waiting for the cloud. Intelligent alerts that adapt to patient baselines, reducing false positives. This approach enables continuous proactive care and ensures issues are caught early. For instance, cardiac patients in Japan used to connect ECG patches that detected abnormal rhythms instantly. Doctors could intervene before emergencies escalated, reducing hospitalization and improving patient outcomes. The next slide talks about the clinical decision support, AI-enhanced care quality. Clinicians faced overwhelming amounts of data. AI helps by augmenting their decision making. It supports evidence-based recommendation aligned with clinical guidelines. Risk stratification to identify high-risk patients. Medication management to detect drug interactions. Diagnostic assistance with analysis of labs, imaging, and symptoms. AI doesn't replace doctors, but it frees them to focus more on patients. For instance, at Memorial Sloan Kettering Oncology, AI-based system suggested chemotherapy options based on thousands of clinical guidelines. Doctors still made the decision, but the AI saved critical time and reduced errors. Here in the next slide, we'll be talking about the patient engagement and accessibility. A strong platform must empower patients directly. This means inclusive design with large fonts, voice input, and high contrast modes. AI powered translation for multilingual support, adaptive content tailored to patient literacy levels. When patients can understand and manage their health, outcomes improve. So, like in Brazil, a multilingual chatbot delivered medical advice in Portuguese, Spanish, and local dialects. By breaking language barriers, it gave undeserved communities better access to care. So even people who don't understand the language, because of this multilingual chatbot, they can understand what the gadget is telling them, kind of stuff. So in this slide, we'll be talking about the scalability and performance, engineering for healthcare integration. As adoption grows, healthcare platforms must remain reliable at scale. This requires microservice architecture for independent scaling, cloud native deployment for elastic capacity, database optimization for fast massive data handling, robust APIs to integrate diverse healthcare systems, performance monitoring to detect issues proactively. Scalability ensures platforms can serve populations, not just individual clinics. Suppose, for instance, during COVID-19 vaccine rollouts, scheduling platforms scaled overnight to manage millions of appointments across entire countries without any downtime. In the next slide, we'll be talking about implementation strategies from concept to clinical deployment. Building platforms is only part of the challenge. Deploying them safely into clinical environments is equally critical. This means using agile methods adapted for regulatory cycles, conducting clinical validation with diverse patient populations, running pilot programs to test safely in controlled settings, supporting change management through staff training and gradual rollout. Success depends not just on technology but also on the adoption and trust. A US children's hospital piloted its asthma management app with just 50 families. After refining the experience, they safely expanded it to 10,000 patients. That's a great breakthrough. So, in this slide, we'll be talking about the future directions of emerging technologies and healthcare platform evaluation. The future of healthcare platforms is being shaped by emerging technologies like edge AI computing to run advanced models locally, federal learning to train federated learning to train models collaboratively without sharing raw data, augmented reality to support doctors during surgery or patient care, voice first attendance for natural hands free interaction. These advances will make more intelligent, accessible, and personal. For example, surgeons in Toronto used AR headsets to overlay imaging on live anatomy, reducing surgery times and improved accuracy. Here we talk about the strategic benefits of AI-powered healthcare platforms. AI-powered platforms create values across the healthcare system, like clinical efficiency by automating risk tasks, patient engagement through personalized insights, care coordination by connecting providers, preventive care using predictive analysis, resource optimization for staff and supply chains, regulatory compliance via automated reporting. The impact extends beyond patients to the entire healthcare system. In Germany, an AI scheduling system optimized nurse shifts, reducing overtime by 20% while maintaining the quality of healthcare. So, this is the conclusion. The strategic imperative of this one is to wrap up platform engineering gives us the foundation for health, gives us the foundation healthcare system requires. And also, native mobile development provides responsiveness, security, and device integration. And apart from that, embedded AI transforms platforms into intelligent companions. Together, these approaches make healthcare safer, smarter, and more scalable. Singapore has already shown this with the national AI powered health apps, which unify patients' records, monitoring, and services. This demonstrates how platform engineering can be a true strategic imperative, not just a technical choice. Thank you all for your time and attention. The convergence of platform engineering, native mobile design, and AI is not just about apps. It's about reimagining healthcare itself. I hope this session gives you a clear perspective on how the foundations enable platforms that truly make a difference in people's lives. I would like to take you. I would like to thank you all for giving me an opportunity to present this topic. Thank you. Have a good day.